In the previous video, we played a game called Can We Predict What the Router is Going to Do with an Incoming Packet by looking at that IP packet, looking at the destination IP address, then comparing it to the routing table and find the longest match and then route based on that longest route in the routing table. So we started off with two examples or two IP packets. So in this video now, we're going to take it a step further and use some additional IP addresses as we consider and predict what the router is going to do when it receives those packets based on its current routing table. So let's take a look at our plan and then we'll go right to the lab. So in the previous video in lab, we took a look at what router 3 would do if it received packets to 10401 or packets to 10404 based on its routing table. We're going to continue that discussion asking ourselves, well, if we were router 3 and we had that existing routing table, what would we do? Would we route it? And if so, which route are we selecting, or would we drop it? So we get to continue that discussion, and the next packet we'll look at is a packet destined to the IP address 104025, and the big question is, what will router 3 do with that packet? So here in the lab environment on our management PC, which is DCNUG, and a console open to R3, let's do a show IP route, and we'll thin out the herd by just doing 10.0.0.0, and we'll hit spacebar to look at the end of that. And let's put up our target IP address, which is 10.4.0.25. And the question is, what will the router do? Will it route it? And if so, which route will it choose from its routing table to make that forwarding decision? So just because of the first 3 octets or 10.4.0, it looks like these all may be in the running. However, we need to take a look at the last octet to make sure. So we can put check marks as far as matching on the 17-bit, the 20-bit, the 23-bit, the 24-bit, but the 26, 29, and 30, just like we did in the previous video, we probably want to check those out. Let's start off with the /26. So if we put our table up, 128, 64, 32, 16, 8, 4, 2, and 1, and we're dealing with the 4th octet here, a /26 is going to be this in the 4th octet here. It's going to be 24 as the starting point, then 25 and 26, and that's the mask for a /26, which also means that the block size for that /26 network is going to be 64, meaning the first network here would be 10.4.0.0, and in that 4th octet, the next subnet would be 10.4.0. and we'd add 64. So the range for this 10.4.0 network with this /26 mask is .1 all the way through 2 less than the next subnet, which is 62. So for the /26, this IP address of 10.4.0.25, boom, that fits. That goes into that network. So that is a match. I'll go ahead and circle the 26-bit network, and that is going to be a match. And let's go ahead and take a look at /29. So for a /29, starting with that 4th octet, 128, 64, 32, 16, 8, 4, 2, and 1. For a /29, this is the 24-bit boundary. This is the 4th octet. So we'd have 25, 26, 27, 28, 29. There's our dividing line between network on the left and host on the right, and our block size is 8. So if the network is 10.4.0.0, the next subnet, because the block size is 8, the next subnet would be 10.4.0.8. So the range for the 10.4.0 network would be 10.4.0.1 through .7. And as I look at this destination IP address of 10.4.0.25, that means that this 29-bit network is not a match. And that would also mean the 30-bit network is not a match. So the winner for this destination IP address should be this 26-bit network. And how do we prove that? Well, we can just ask the router, what route would you use? And it'll just happily tell us. And to do that, we'll do a show IP route space, and then we'll put in the IP address that we're after, which is 10.4.0.25. Press enter, and survey says, pew, pew, pew. There's our 26-bit network, just as we predicted. So I want to point out that this is a skill about predicting which route will be used. It's a skill that needs to be developed or gets to be developed. The more you practice with it, and that's why I'm walking you through several examples in the previous video and also this one, the more you practice with it, the more you can catch on to the idea and the better you can get at it. And eventually, if you do this enough, you can just look at the routing table. It's amazing to see people do it. But when they work with the same network all the time, they can just look at the routing table and say, oh yeah, that's it. Where if we're just starting off or we're in a brand new network environment, it may take a little bit more time to verify what the ranges are for a certain network and then identify whether or not a given IP address falls into that range. So this is an important skill, and it gets better and faster over time. And by the way, it's also worth it to invest the time in practicing and getting good at the skill because it's going to improve your overall skills with IP networking in general. So let's go back to the CLI and let's take a look at another destination IP address. The next one I'd like to do is 23.1.4.5. Let's do that one next. So back at R3, if we did a show IP route and pressed enter, and these are sorted numerically so we can use a space bar, and I'll pause it right there because I don't see any 23 networks in the routing table. Because if they existed, they would be somewhere between 10 and 172. So I don't see any 23 networks. Now, does that mean that this router, if it gets a packet destined to 23.1.4.5, is it going to drop that packet? Well, it's not specifically in the routing table as an explicit route, but if this router has a default route, it will use the default route as a last-ditch effort to forward the packet to 23.1.4.5. And the way we can check that is just doing a show IP route, press enter. And I'm not going to hit space or enter to advance the screen. I just want to look at this information right here. It has a gateway of last resort. And that's 10.13.0.1, which is R1, who's providing a default route. And it's also right here as well. So the default route learned via OSPF has an XTOP of 10.3.0.1. So R3 says, well, if I got a packet to 23.1.4.5, router 3 would say, well, I don't have an explicit route for 23 anything, but I do have a default route, and I'll use it. And so it would use the default route and the egress interface and the XTOP to go ahead and forward that packet onto that XTOP router, who would then be responsible for continuing to forward that packet to the destination of 23.1.4.5. So to answer the question, route or drop, we're still routing. In this case, we're using the default route. So we did the 23.1.4.5. Next, let's do the 172.16.8.25. A packet going to that IP address. What, if anything, will router 3 do when it receives that packet? So back to R3, we'll just show IP route, space, and let's go ahead and do 172.16.0.0 and take a look at all the 172.16 networks. And as a reminder, it's 172.16.8.25. And if the router receives a packet to that destination IP address, which of these routes, if any, match that? Now, I can tell you visually that this one looks like a winner, 172.16.8.0, but that last octet is sliced and diced a little bit, so we need to take a closer look at that. So let's take this network, the 172.16.8.0/27, and let's figure out the range for this prefix for that network, and let's see whether or not this destination IP address fits into that range. And if it matches, the Cisco router can then use this route to forward this packet onto its destination. So I've got a question for you. How do we go about identifying the range of IP addresses for that specific network or for that specific prefix? And the answer is we're going to do it the way we've been doing it in the previous few examples. And that is we'll put the table up of the values for the 8-bit positions. We'll identify the block size. We'll identify the next network. And then we'll put the range in. That's an important skill. And that's why we're bringing it up again and again to help reinforce those skills. So I would encourage you, as we go through these exercises together, is to participate and actually practice writing those out to get better and better at identifying the ranges of specific networks. So let's build our table. This time we'll start from right to left. We'll go 1, just double, 4, 8, 16, 32, 64, 128. And we'll imagine that this is our 24-bit boundary and that this is our 4th octet. So with a 27-bit mask, starting at 24 would be 25, 26, 27 for the mask, and that would be the dividing line between network on the left and host on the right. These would be zeros for the mask. And most importantly for this discussion, because the least significant bit of the mask is right here, that's our block size. So for this network, 172.16.8.0 with a /27, this is the network we're looking at. The next network would be 32 more. So it'd be 172.16.8.32. And the next network would be 32 more, 64. And the next network would be 32 more, 96, and so forth and so on. So this helps us in identifying the range of addresses for this network that we're looking at right here. So the starting address would be .1, and the last address, the last usable address, would be the next subnet, which is 32, minus 2. And that would leave our last IP address in this subnet of 30. So the question would be, does this IP address fit on that subnet, on that prefix? And the answer is Yes, it does. So that would be our match. So we can verify that by going to the command line interface here on R3 and issuing the command show IP route. And then we'll simply plug in that IP address of 172.16.8.25. Press enter, and it's going to show us, boom, there it is. There's the match, that 27-bit network. And what I'd like to do is take that one step further and give you one more IP address that we can work through together to identify which route, if any, the Cisco router will use to forward a packet. So let me go ahead and clear off the screen a little bit and do a show IP route. And let's also do that for 172.16.0.0. And let's plug in our target address of 172.16.8.50. Great. So the router receives a packet with this destination IP address, and the question is, which of these routes are going to match, if any? So in the routes, because these routes are all longer than 24 bits, that third octet of 2, 4, 6, 8, 10, 12, those are locked down. Those are not being split at all. So if this route is going to fit in any of these routes, it's going to be right here, but we'd want to do the long math and verify whether or not this IP address fits in that range. Now, from a moment ago, we just did the math on this specific network and identified the range, but we're going to do it one more time with my encouragement to please practice this on your own so you can go ahead and verify it as well. So we're going to put our table up, 1, 2, 4, 8, 16, 32, 64, I'll fix that 2 there, 128, great. And this is our 24-bit boundary right here. And we're going into the fourth octet, 3 more bits, 24, 25, 26, 27. So there's our mask in binary. Here's our least significant bit of the mask, which is our block size. So the network 172.16.8.0/27. The next subnet is going to be 32 more in that last octet. So it's going to be 8.32, and then 8.64, 8.96, adding on and adding on to 32. So the range for this network would be .1, the first valid host address, through 30. And this IP address right here, 172.16.8.50, does not fit in that IP address of that prefix or this network. And as a result, this network, this 27-bit network, is not a match. So what is the router going to do? Is it going to drop the packet? Is it going to do something else? And the thing that a lot of people forget is that the default route is usually present or configured on most devices, on most routers. And as a result, if there's not an exact match in the routing table, it'll default to the default route and use it to forward the packet with whatever the default route says to do. So if we did a show IP route and pressed enter, and I'll hit any key except for enter or space to stop the output, we do have a default route that is currently set up with the next hop of 10.13.0.1. And so if we had a packet that was destined for 172.16.8.50, although it didn't match any of our more detailed or longer routes or prefixes in our routing table, it will match on the default route. And this router would forward the packet to this IP address using the default route. So in this video and lab, we continue the game of predicting what the router will do when it receives a packet, looks at its destination IP address, and then compares it to its routing table looking for a match. So I have really enjoyed taking some time to do it longhand, with the bit values and identifying the block sizes and what the ranges were, and then figuring out where that IP address fits in that range. And the more we practice with this, the more we do it, the more comfortable we will become in doing it. So I encourage you to have a lot of fun as you continue working with and predicting what the router is going to do with the packet based on its routing table. So thanks for joining me in this nugget. I'll see you in the next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.